Hello, my name is Bradley Van Dam, and I will be doing questions 2 for Chapter 26 for our exam, Chapter 26. So let's get started. So in 2.1, it says we have 3 resistors, R1, R2, R3, with corresponding resistance of 1, 2, and 4 ohms, and it wants us to find the equivalent resistance for the combination. Okay, so we can use equivalent resistance equals, and then just simply the sum. So I'll just say, oh, that's sum of all R, yeah. And then we'll just say 1 plus 2 plus 4, so that's 6, 7. I won't have to just write that out. So yeah, just the sum of all of the resistances, so that is 7 ohms. Part B says to find the equivalent resistance of the combination shown in figure 2. So then we do, okay, so I remember in that case, we're going to do 1 over equivalent resistance and do this time, the sum of 1 over R for resistance 1, 2, and 3. So I'll write that one out. That's going to be 1 over 1, which is 1, plus 1/2 plus 1/4. So I'll just say 1 plus 1/2 plus 1/4 is 7/4. I'll just leave it in fraction form. Ohms. Okay, and part C says to find the equivalent resistance for a new combination. So, okay, so for in this one, we're going to use equivalent resistance R EQ equals, so we do R1, but then we do plus R2, which is parallel R3, and that's the same as saying R1, and then some parallel here, plus, instead of writing R2 times R2, I'm just going to say R2 squared, lots of 2's, and then that's going to be, what is that? Yeah, R2 plus R3. So 1 plus 2 squared is 4 over 2 plus 4, which is 6. So 1 over 4 over 6, or 1 plus, which is 5/3. So there's a 5 over 3. Okay, plus 1. There we go. 2 point. What is that? 2.1, 2. R2, 2 squared. 4, 6. What are we doing here? Okay, yeah. I don't know what I was thinking. Thought I did something wrong. 2.6. I say 7. And that is ohms. But, oh, wait, hold on. 5, 4. 6, 1, 2. Okay, let's get to part D. Okay, so find the equivalent resistance for the combination, so a new combination. So let's call this, this new one R prime equals R2 plus R3. And then, so that's, yeah, so that's equal to, R prime is equal to 6 ohms. but we were asked for the equivalent resistance. So when you solve that, so then we do R EQ, which is now what we're solving for. It's just R prime parallel to R1. Yep. So again, it's going to be okay, so in this case it'll be R prime R1 R prime plus R. Actually, yeah, wait, hold on. I think I might have, let me fact check myself really quick. So R squared. Oh, then I'm going back to the other problem just to check my work. 2 over 6. Okay, that's what I had did on. So it's not, for this, it is not 1 over, or it's not R2 squared. It's actually R2 times R3. I got that mixed up in my head. So that's, instead of 4 6, it's 8 6. So that's 2.3 repeating instead of 6 repeating. Okay. I was going to say, I don't remember being the exact value when I was solving it out, but okay, so that works out. So now we're doing the equivalent resistance. So it's R prime parallel to R1. So R prime times R1 over R prime plus R1. So we have 6. So 6 times R1, which is just 1. So we have 6 over 6 plus 1, 7. So we do 6 divided by 7, 0.857. Okay, so that is that all? Yeah, okay, so that's all of part, or question 2.1. 2. So it says we have 3 resistors again, so R1, 2, and 3, but this time the resistance is 4, 5, and 6 ohms respectively. And it says the terminals of a battery with EMF of 24 volts. So first I'll just write out R1, 2, 3 equals 5, 6. And was it? 4, 5, 6. And that is ohms. And then we're given battery with EMF of, I think it was 24 volts? Yes, 24 volts. Okay. 4 volts. And, okay, the terminal with battery and negligible internal resistance are connected to points A and B. And it says the question is asking to find the current through the battery. Okay, so current I. Okay, so first let's solve, in this case, first let's solve for, how do we want to approach this? Let's solve for R2, 3. So that's just going to be the sum of 2 and 3. So I'll just say, yep. It's going to be 5 plus 6 is 11, so 11 ohms. Okay, so now let's do the equivalent resistance. REQ equals, okay, it won't be, I don't think it's, yeah, no, it's not regular. It's 1 over REQ. And then we do, again, like before, the sum of all 1 over resistances. So there's 3, so then we would get 1 over 4, or 1/4 plus 1/5 plus 1/6. Actually, no, I'm sorry. We wouldn't do that. We do 1/4. So yeah, so we do, let me erase that. That's not true for this problem. So then we have 1 over R1 plus 1 over R23, which we just calculated. So that's going to be 1/4 over 1/11th, or 1/4 plus 1/11th, sorry. Three, 4, 0. Did I do something wrong here? I think I just have to put it in fraction format. No, I don't think that's... Q... Okay, I see what I did wrong. Okay, so that's actually 2.93, sorry. And then we have to solve for the current through the battery. So let's semicolons, and now we found R23 and one of our equivalents. So we can solve for I of B for battery equals V over REQ, our equivalents, and given 24 volts, 24 over 2.93, that is 8.10. 8.18, sorry. That is current, so that's in amps. That's part E. So part F wants us to find the current through just R1. So in that case, we could do this. Sorry, we can do, so solving just for the current through R1, I of R1 is equal to, we just say V over R1, so only R1 exclusively. 24 over 4, and that's just 6. So we get, so for individually just through R1 is going to be 6 ohms, or not ohms, 6 amps. Just looking at that guy, 6 amps. Okay, and then for part G, says to find the current through R2. So then we do, in this case, we're going to do I, but for R, through R2. Okay, so yeah, like we said, so it's going to be R2, 3. So this is both going to be the same for going through the current going through R2 and R3. So this is going to cover two parts of the question, or two questions, I guess, because in part G asks for the current through R2, but for part H asks for the current through R3. So this is going to be, just like we did before, V over, this time it's R23. So 24 over 11. Let's do that out. 2.18 repeating. That is amps. And I should square that off as my answer. E, and that's F. And like I said before, this is going to be for both R2 and R3. So this is G and H. And okay, so now we're on 2.3. We have 3 resistors again, R1, 2, and 3, corresponding resistance of 7, 8, and 9 ohms. So Again, same deal. 7, 8, and 9 ohms. It says the terminal of a battery of EMF 12. So now we have, I'll just do this as the EMF. It's 12 volts. Negligible internal resistance connected to point A and B. Find the power output of the battery. Okay. Excuse me. So first, let's solve for our equivalence. Let's do, okay, so yeah, we're going to do 1 over equivalence. So this time it's going to be 1 over R1, 1 over R2, 1 over R3. So that's 1/7 plus 1/8 plus 1/9. So 7th oh. .504. Okay. Okay, yeah. 2.64. And then we get, this is the equivalence, and then now we're going to look at solving for our current here. So for I, and we now know equivalence over V equals, so it's going to be 12 over that 2.64 we just calculated. I would say 4.55. 55 amps. And now to solve for power, since we have EMF and the current, so that's P equals I 12 times 4.55. $54.6, and that's going to be in units of watts for power. Part I. Yep. So part J wants us to find the power input to R1 individually, and then K and L is asking for power input to R2 and R3 respectively. So it's going to be pretty similar process to this, but we are going to, what is it? We're going to, in this case, okay, so for individually, we're going to do power. So P equals, actually, I'll say, it's going to be repetitive again. Remember this problem. It says P1, comma, P2, comma, P3. So that would be for parts J, K, and L. We are going to have the equation P equals V squared over I of, I'll just say 1, comma, 2, comma, 3, because that's the repetitive nature of it. All we're doing is just changing whichever current we're using. So this is going to be, what is that? 12 squared. 12, yeah, so 12 squared, and the only thing that's changing is the current below. So 144 divided by 7, comma, 144 divided by 8, comma, 144 divided by 9. So I'll just do that out, 144 by 7. So that's the first power for R2. That's for R3. So I think that was, yeah, 20.6 20.6 watts, comma, 18 watts, comma, 16 watts. Just to knock that all out instead of like rewriting this every single time. So that is for parts J, K, and L. Now the last question, 2.4. Again, another problem where we have 3 resistors of R1, 2, and 3 equaling 5, 6, and 7 ohms. This time the EMF is equal to 9 volts. And this one is asking for the power output of the battery. So, excuse me, asking for the power output of the battery. So, for this, we need to first solve, first let's solve for R23. R23. Okay, and so parallel 2, 3 divided by their sum. Uh, 42, 13. Okay, so equivalent resistance. Okay, so now we're only going to consider in this problem, we're only going to have to consider R1 and R3. So what am I saying? No, we're only going to have to consider R1 and then the parallel. So R23, we just solve that, 42 of 13. So 5 plus 42 thirteenths. (107 thirteenths). 8.23. So we're asking for the power output of the battery. So what else do we need here? We need current. So we're going to need total current. So then we can eventually solve for P battery. So we'll say net equals, it's going to be V over equivalent resistance. So 9 over 8.23, 1.09 amps. And what else are we going to need? So we just solve for the net current. So now let's solve for, let me see, for current. Yeah, okay, so now let's solve for let me put it up here, R2, which is, we have to consider the total amount. So I net 1.09. So I net plus, or sorry, not plus, multiplied by the, what is this here? R3. Okay, so that's R3 over R2 plus R3. So that's going to be 9 times 7 divided by 2, 3, 6, 7/13 again. So 7/13 times 9. 4.84. That doesn't seem right. Should be, maybe, let me see here. Is it? Oh. 7. No. I don't think so. No. 9. Oh, 9. Well, what am I talking about? It's not 9. It's 109. Okay. So I was going to say that looks a little more accurate. So 0.59. Let's just round that. Oops. So it's for R2. And this will eventually, there's parts N, O, and P are going to ask for the power output, or power input, sorry, to R1, 2, and 3 respectively. So this is also going to be useful for this as well, so solving for these individually. So, and then we have, and let's do R I of R3. So this time it's going to be I net times, not I, sorry, R2, and then over the sum of the two again, R2 plus R3, that's not changing. So this is going to be 1.09 times 6 divided by 13. So let's just change that to a 6. Okay, so we get 0.5. Oops, sorry. Amps. And now we can finally solve. Actually, no, I guess the way I was thinking about it, we actually didn't even really need these two guys yet. We just really needed to solve for net to solve for the power of the battery. So I guess I saved myself, I didn't really save myself time. I guess I just kind of did it in a wonky order. So for the power of B battery, let's say, so it's going to be V, so EMF times I net. I don't know why I'm not sure why I had that thought process, but that'll help us. These two values will help us calculate the individual power inputs. So here, let's see. We can do, so that's just 9 times I net 9 times 1.09, 9.81. So that is in watts, and that's for the battery, which is question part M. I'll say M. And then for the last three parts, similar to like these ones, we can kind of write it out in a, obviously it's not going to be the exact same, but we can just do the power for R1, 2, 3, instead of having to rewrite out this every single time. So we can say now for P1, 2, 3 equals the EMF, so V times the current squared, and that's going to be for each individual case. So solving for power, so we're going to have 9 stay the same, so it's going to be 9 times, I'll actually just put parentheses, 1, okay, yeah, so I'll just do, I'll put it like this. So I'll say 1.10 or 1.09 squared, comma, and then I'll just rewrite out these two values. So for R2, 0.59 squared, comma, and then for R3, 0.5 squared. And for each of those cases, we're going to get different answers. So 9 times 1.09 squared, we get, actually, let me see here. 9, 1.0. I'm doing something wrong here. Hold on. Oh, wait, did I? No, it doesn't look right either. Let me see. Okay. Oh, okay. Yep. Yep, so I did. Okay, yep. So this guy's not going to be the 10.6 that we had gotten before, so it's going to be 5.98, and then that's in watts, comma, yep. Okay, I see now. Yep, so 2.08, and then 1.78. So again, that's starting to add up better. I was about to say, something looked kind of funny. So that's going to be for parts N, O, P. So that wraps up all of the work for Chapter 26, Exam 26.